In this video, I was planning on talking about binary numbers, why it's helpful to know about binary numbers for C++, and then I was planning on going through a couple binary number examples. So I'll show you how to convert a couple of decimal numbers to binary, including a fraction decimal number. So first of all, binary numbers are, well, just coming to why we even need them. Modern computers use electricity, and microchips, in a microchip the electricity is either on or off, and so this naturally leads to a binary state. So for instance, if you have 0 voltage, or if it's 0, this would be off, and then if you have a low voltage, and this could be like 3 or 5 volts, that would equal on. So in order to understand binary, it's helpful to review base 10 real quick. So base 10 is the number system we're used to, the decimal number system. And base 10 has 10 symbols, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And just looking at an example decimal number, so 3,567, the 3,000 is in the thousand spot. So this is literally saying you have 3 1,000ths, so this would be like 3 times 10 to the third. And then the 5 is in the hundred spot, so this is literally saying that you have 5 100ths, so this would be 5 times 10 squared. The 6 is in the 10 spot, so this is like saying you have 6 tens, so this can be rewritten as 6 times 10 to the 1. And then the 7 is in the 1 spot, and so this is literally like saying you have 7 ones, or 1 is equal to 10 to the 0, so this can be rewritten as 7 times 10 to the 0. So the important thing to recognize with this decimal system is that as you move to the left, each digit is 10 times greater than the previous digit. So this is how this is done with 10 symbols or base 10 system. So then coming back to the binary, where we really only have these two states, either on or off, what if we only have 2 symbols, like we only have the 0 and 1? Well, the rules are still the same as if we had base 10. The only difference is the digits as you move to the left, the digits are 2 times greater rather than 10 times greater. So an example of this would be, let's look at this binary number. So 1001 is actually equal to 9 in decimal, but to figure that out, or to write this out, we have in the thousandth spot, we have, or I guess it's not really thousands in the binary system, but in the equivalent spot to the decimal system, we have 1 times 2 to the third, and we have a 1 because there's a 1 right here. And then we have 0, so this is 0 here because we have a 0 in the binary number right here, so 0 times 2 squared. And then for this next spot, we have 0 times 2 to the 1 plus, and then we have a 1 here, so this is 1 times 2 to the 0. So if you actually go through this math, you end up with 8 plus 0 times 2 squared is 0, plus 0 times 2 to the 1 is 0, plus 1 times 2 to the 0 is 1. So we end up with 8 plus 1 is 9. So that's how you end up getting 9 from this binary number. I want to show you how to convert a decimal number into binary. I think the previous example I had up there, it showed you how, if you have a binary number, how to go to a decimal number, but I want to show you how to go from a decimal to a binary number. So let's say we have 13, and we want to convert this 13 to binary. So there are a few different ways to do this, and so I'm going to show you what I think is the most straightforward way if you're just beginning. If you know another way, or if you see another way to do it that you think looks better, then you can certainly do it that way. But just to start, what I like to do is first of all write down the powers of 2, because what you're really doing is figuring out what powers of 2 you need to make this number. So first of all, we have 2 to the 0 is equal to 1. 2 to the 1 is equal to 2. 2 squared is equal to 4. 2 third is equal to 8. 2 to the 4th is equal to 16. 2 to the 5th is equal to 32. 2 to the 6th is equal to 64. And 2 to the 7th is equal to 128. And since we're only converting 13, we don't actually need anything above 8 here, but I wanted to write down these others for some of the other examples I'm going to do. So and one thing to notice about this is as we increase the decimal places, so this is moving to the left, your number is increasing as a multiple of 2. So we go from 1 to 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32, 32 to 64, 64 to 128, and so on. We could keep going with this. So for 13, we want to figure out how we can get 13 using these numbers. So first of all, 16 is more than 13, so we're not going to use 16, so we can go back to the next number. So we have 8. So 8 plus 5 is equal to 13. We want to figure out what numbers we can use to make 5. And so the next smallest number after 8 is 4. So 4 plus 1 is equal to 5. So then we can just fill in what numbers we need to make this binary number. So if we just assume, like I'm just going to assume this is 5-bit, I guess. So 1, 2, 3, 4, 5. And I'm just going to write in what the different numbers are for these spaces too. So this is the 1, 2, 4, 8, 16, 32. And we don't actually need 32, I guess. So this is, so this would be 5 bits. So, and we don't need the 16 either. So let's just say this is a 4-bit number, I guess. So first of all, we have an 8, so we can put a 1 in the 8 spot. We have a 4, so we can put a 1 in the 4 spot. We don't have a 2, so we put a 0 there. And we have a 1, so we put a 1 here. And so this 1101 is equal to 13 in binary. And you can check this by just summing the numbers. So 8 plus 4 plus 1 is equal to 13. Or another way to write this is to go back to this 2 to the 3rd, 2 squared. So 2 to the 3rd plus 2 squared plus 2 to the 0 is equal to 13. So let's do another example. Let's do a little bit bigger number this time. So let's do 75. So we already have our chart here of the numbers we're going to use to make the binary number. And so for 75, first of all, 128 is larger than 75, so we know that we need to go back to the 64. So we have 64 plus 11 is equal to 75. So now we want to break up the 11, so 16 is more than 11, so go back to the 8. So 8 plus 3 is equal to 11. And then I want to break up the 3 And so the 4 is greater than 3, so go back to the 2. So we have 2 plus 1 is equal to 3. So I'm going to write down the binary digits for this. So I have 1, 2, 3, 4, 5, 6, 7. And so this is 1, 2, 4, 8, 16, 32, and 64. And just to remind you, remember this is 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1, and 2 to the 0. So all I need to do now is fill in which numbers I used to get 75. So first of all, I have a 64, I have an 8, I have a 2, and I have a 1. So I want to put 1 in the 64 spot. I don't have a 32, I don't have a 16, I have an 8, I don't have a 4, I have a 2, and I have a 1. So if you sum these, 64 plus 8 plus 2 plus 1 is equal to 75. So this number is equal to 75 in binary. Now I want to show you an example if you have a fraction. So let's say that we have 40.15625, and we want to write this in binary. So it's easiest to look at this problem as two different parts. So the first thing you want to do is put the 40, or the first part of this number, into binary, and then you put this component after the decimal into binary. So 40 is pretty easy. It's just 32 plus 8. And so if we write that down, so 1, 2, 3, 4, 5, 6, 7. So this is 2 to the 0, 2 to the 1, 2 squared, 2 to the 3rd, 2 to the 4th, 2 to the 5th. And just to write in what these are real quick. So 1, 2, 4, 8, 16, 32. So I have a 32, I don't have a 16, I have an 8, I don't have a 4, 2, or 1. So this 1, 0, 1, 0, 0, 0 is the binary equivalent for 40. And I'm just going to erase some stuff real quick, and I'll show you how to do the fraction. The fraction is a slightly different process, and it's pretty easy if you just follow the steps. So first of all, I want to write down the fraction, or this part of the number. So 15625, and I want to multiply that by 2. So I have 0.15625 times 2, and this is equal to 0.3125. And since this is less than 1, I'm going to put a 0 right here. And then I want to take this number, the 0.3125, so 0.3125, I want to multiply that by 2 again. And this time I get 0.625. This number is less than 1, so I want to put a 0 here again. And then I want to take this 0.625 and multiply it by 2 again, so I have 0.625 times 2, and that's equal to 1.25. And this number is greater than 1, so this time I'm going to put a 1 right here. Now I take the 0.25, multiply that by 2 again. So notice I'm only taking the 0.25, not the 1.25, so I have 0.25 times 2. This is equal to 0.5. This is less than 1, so I put a 0 here. And then I'm going to take the 0.5 again, multiply it by 2. That's equal to 1, so I'm going to put a 1 right here. So the binary equivalent of 0.15625 is 00101. I'm just going to write that real quick. So 0.15625 is equal to 00101 in binary. And you can verify this by taking so you can take 0, so we have a 0 here, so this would be times 2 to the minus 1 plus 0 times 2 to the negative 2 plus, and then we have a 1 here, so this is 1 times 2 to the negative 3 plus, and then we have a 0 here, so this is 0 times 2 to the negative 4 plus, and then we have a 1 here, so this is 1 times 2 to the negative 5th. And if you go through the math and add these up, you should end up with the 0.15625. So then the way you get the 40.15625 is just combine these two numbers. So we have 1, 0, 1, 0, 0, 0 for the 40.00101 for the 0.15625. So this is equal to 40.15625. You might be wondering why we would even want to know about binary numbers for writing code in C++. It seems like, well, we're not programming zeros and ones. We don't really see any of this in our code. The computer takes care of all of this for us. And the main reason is because when you're writing your code, you need to pick, so with C++, you have to tell the computer what type of variable you have. And we'll get into variable types later, but basically your variable type has to do with how the number or letter is stored in binary. And so if you understand a little bit about binary, enough to know how the numbers are stored, how the different types of, like, say, floating point works, then it makes it much easier to pick the right data type for your variables when you're writing your code. If you didn't understand at least a little bit about binary when you're writing your code, a lot of the declaring the data types for your variables would boil down to just guessing what you need. And so just having a basic understanding of this is really helpful for writing your code. It's also really helpful for figuring out certain types of errors, like if you're having a overflow error or a precision error. This can help. Having an understanding of binary can help to figure out what your error is. So in the next video, I'm planning on talking about how to write negative numbers in binary, because we've only been talking about positive numbers. And I'm going to do some future videos on how to add binary numbers, and in a computer the algorithm for adding is also used for subtraction. And so if you know how to add binary numbers, you also know the algorithm for subtracting binary numbers. And I want to talk about the IEEE 754 floating point. Thank you.